See, now we are going to talk about Docker actually. What is the Docker? You know, why we need Docker. So, whenever we are talking about some technology, we need to know what is the use of that particular technology, why we need that technology. So, one of that is Docker now. So, Docker is a container management tool actually. If I talk about Docker, okay, Docker is a container management tool. Now coming to a term container, what do you understand by container? I have one picture here. I have one, I downloaded one graphical representation, so you can see here my GUI picture. See here, this look like kind of boat. Kind of boat means there is a box here. There is a box here, so you can see these boxes can say you these are container of application. Inside application will be packed in certain environment, in a fixed environment, that is called containerization, and that will be on some platform. Before that, I am giving you one difference to make you understand what Docker is actually. See, whenever we have one any kind of desktop or any kind of virtual computers, or this is a virtual machine VM, and this is in case of a Docker. I am giving you one proper small difference of the things, how we came across Docker, why we needed Docker in our industry. This is Docker here. This is a virtual machine here, VM. If I talk about VM, that is a virtual machine, how virtual machine work. And this is my physical server. What is the physical server I'm using? This is my physical server. Now, see, in any case here, I have one thing. In physical server, what I have a hardware here. If you talk about hardware means any kind of a if I talk about hardware means that includes RAM, our processors, our hard disk, basically hardware here. I'll have a hardware here, and then here operating system, and above operating system there will be application running here. There will be application running, and application can be of any types, right? Just the application running inside. So what is the problem of why we shifted to a Docker? Why we shifted from physical to a virtual machine, and then afterward from virtual machine to a Docker? What was the reason? So main reason behind this is, see, configuration. I'm just taking example of some kind of configuration here. I have some kind of configuration here. If I have some kind of configuration here means I have suppose I have a RAM of around 16 GB. I'm taking example of 8 GB. Let it keep. I have a RAM of 8 GB. This is just a suppose. I'm supposing this configuration here. In physical computer, I have my this configuration. So I'm taking an example of HDD now. Hard disk that is of 1 TB. Okay. See, in physical computer or laptop or physical center, see, suppose if I have a 8 GB of something. Okay. So you can check here. You people can check here. See, how much is my configuration here? This is 232 GB, and free is 133 is free. 133 GB is free. So my mean to show you people this is we are wasting our lot of hardware resources here in case of physical centers. Like if I have 8 GB of RAM, I am not utilizing my 100% of 8 GB. If I have a hard disk of 1 TB, whatever the hardware configuration I have, there is no 100% utilization of that particular hardware. Okay, there are so many kind of that, like of that. So if I am giving example again, I am coming back again here. This is the thing here again. I am coming back to uh, now again I am coming back to again I am giving example of Facebook. As people know, they are producing 5 to 6 PB of data. PB means petabyte of data. If we talk roughly means that comes around 5 to 6 lakh movie in a day, and the size will be approximately 2 GB. Should be approximately 2 GB. So means, let me repeat actually the people who joined later. So for them it will be confusing. So see why we need Docker. We are going to talk about Docker. This is normal class actually. This is not a demo session. So people who are newbie here, they can see my study pattern, study style. For that I joined them. So see why we need a Docker actually. People are talking about Docker, Docker, Docker all the time. Why we need Docker? You know, if we go to market, right, we have some requirement, right? We have a reason why we need that. So same here, why we need Docker? You can see the image of Docker here. This is the image of Docker here. GUI representation of user interface of Docker. So if you can see, if you people can see, there is a boat here. Above boat, there is a packets here. These are called containers. Inside container, these are called containers of application. Application will be packed in certain kind of environment. One different environment will be provided, will be created to the images, and those application will be inside the Docker container. Actually, this is called containerization. Docker containerization. So now this is a containerization actually. If I say containerization means that will be same. If I'll say Docker means that will be same. Actually, Docker is just a terminology, but containerization is a relevant terminology for Docker. Okay. Now coming to here. Now, as I said, why we need Docker actually? What was the revolution? Because each and everything starts from revolution, right? It changes from another pattern, it changes from another. So same happened here as well. I have a physical server, whatever the physical server I have. Then afterward virtual machine came into a picture. Then afterward Docker. I'm going to give you a presentation why we needed Docker, what was the necessity of Docker. So see, I gave an example actually. If I have a physical laptop or physical any kind of physical center I have, okay. In physical center there will be like big resources, right? I want you people to think broader way. I don't want you to think centric way. If you think centric way, this is this will be something else then. See, in broader way, if I says means in any physical server we will have a hardware. We will have above the hardware we will have operating system, and above operating system we can download any kind of application. That can be of any kind of application that is as per our requirement. What is our requirement as per our work. So see, talking about hardware resources here, suppose I have 8 GB of RAM here. I'm just taking example of small configuration just to demonstrate you people why we shifted from physical server to virtual machine. So if I have 8 GB of RAM, I'm not using my 100% of 8 GB. Or if I have a hard disk of 1 terabyte, I'm not using 100% of my hard disk space. So as you can see here itself as well. See, if you people can see here itself as well. See, I have this in my local disk C. I have a 232 GB space, but I am not using 100% all the time. 133 GB I have free, but I paid for this. My mean to say is I paid for this, but still I'm not using 100% all the time, right? This is the case with a physical center, and this is the case with everyone, every system. So see, as I'm giving example of 5 to 6 petabyte of data producing. See, Facebook, as I said many time I said, so Facebook is, this is a observation actually. Facebook is producing 5 to 6 petabyte of data. Now think like this: if Facebook is producing 5 to 6 petabyte of data, we need to store all the data there, because otherwise what, how we can see the what we configured yesterday, who is or means data has to be preserved, data has to be saved. That's why we are talking about cloud nowadays, right? Virtual storage we are talking, right? This is the necessity. Okay, so this is the necessity means you can understand now. See, if we want to save this much of data, 5 to 6 petabyte, forget about 5 to 6 petabyte of data. If we want to save like 50 GB of data or 100 GB of data, I'm taking a small data types. So see how much hardware resources we was using here. We are not using 100%. So there will be wastage of lot of hardware resources. And if we are wasting our resources means we are wasting our money. That is directly proportional, right? So this was the case with the physical server. Now virtual machine came into a picture. Same configuration. Machine will have a hardware here. Virtual machine will have a hardware. Virtual machine will have a go guest OS. Virtual machine here. Let me write first. See, virtual machine will have a hardware. Hardware means same kind of configuration. If I talk like 8 GB of RAM, 1 terabyte of hard disk, same operating system OS on OS. See, to overcome this problem. Yes, please. Yes, please. Okay, okay. I'm drawing actually. Yeah, my screen is not visible. Let me stop the representation. Just a second, please. Yeah, is it visible now? Okay. Hardware. So above hardware, I will have operating system here. See, above operating system, many people will know about this one. Hypervisor. Hypervisor. So what hypervisor will do? See, I am not going into hypervisor very deeply. Okay, because it will take at least actually 7 to 8 lecture so to demonstrate this. What is the use of hypervisor actually? What hypervisor do? Hypervisor do the virtualization. Okay, this much is enough for you. Hardware, this hypervisor will do the virtualization and it will do the virtualization of hardware. So my mean to say is, see, whatever the hardware resources we was wasting here, so what hypervisor will do, see, in case of virtual machine, what will happen? So we are creating virtual machine like this. The people who is having experience in virtual machine creation, they will understand what is this. The people who don't have, they need no need to stress. This is not alien technology. This is so simple. So they no need to be stressed on this. So see, in case of each virtual machine, here we will create a virtual machine inside our physical can say physical server inside our physical host can say. Okay, so it will be like this. We will have operating system here. Each virtual machine will have their own operating system OS, own operating system here. So above operating system there will be application running here. See, before that I want you to, many of people you knows, the people who doesn't knows, for them I want to add something here. See, if we are talking about application as a DevOps engineer, if I am talking about application, please you people need to think like this every time. Okay, if I am talking about application, what application will have? Application will have a code, that is a source code. Source code that is written by a developer. Okay, this code, source code is written as per library files, as per configuration file, as per configuration file, and as per dependencies. I'm just writing dependencies. Okay, see, if I'm talking about, if I'll talk about any application, okay, you people need to think like this application will have what? Will have a source code, library file, configuration file, and dependencies all together will make one application. So if I'm talking about application here, means what is running inside here? Library file, configuration file, dependencies plus source code is running here. Okay, so that will run on operating system. See, and what is the another advantage of using virtual machine? If I want to use the different OS in my host, this is my host, whatever the hardware OS and hypervisor I'm talking, this is my host. And if I want a different operating system in my host, if I have an operating system, this is my operating system here. If my operating system is window here, suppose this is my window here, my OS is a window here, host OS is my window, so I can add Linux here. I no need to, no need to be like that, I no need to, it's not like, it's not mandatory I need to install window here on my virtual machine. I can have a different OS here. This is the advantage of using virtual machine. And second thing is, because of this reason we came into a revolution, that is hardware wastage. So what we are doing, see here, if I have a 16 GB of this same configuration, 8 GB of RAM and hard disk of 1 terabyte, let me write, otherwise you will be confused. I don't want you people to be confused. if I have a RAM of say I have a RAM of 16 GB. I am talking about 8 GB, so keep it 8 GB all the time. So 8 GB and hard disk of that is 1 terabyte. If I have a hard disk of 1 terabyte means what virtual machine will do, see I have 8 GB RAM, I cannot, and another thing, and I cannot give equal distribution to virtual machine more than what I have in a host OS. Please consider that. Okay, see, that will be 8 GB, that will be 8 GB, that will be 4 GB. Okay, I'm giving you 4 here, 4 GB of RAM, 2 GB of RAM, 2 GB of RAM. See, 2 GB of RAM, and same it will be in case of hard disk as well. This host OS hardware will be equally distributed. How, why, and who will do that? Who will does that? Hypervisor will do that by virtualizing the hardware resources of host. It will distribute equally, so whatever the resources we was wasting, we are using 100%. Now another thing is if each and everything is good here in case of virtual machine, then what was the use of using Docker then? See, here we are using operating system, and of course if we are using application here as well, here as well, here as well, so there will be a licensing, because if I am using each, if I am using for each virtual machine, if I am using one separate OS, means there will be a licensing fees here, right? This is not free here, right? So at the time I'm creating one OS, I have to pay for one OS licensing fees. So whatever the cost we was putting on hardware, here we end up on putting that on OS operating system. So we are we are all about same here. So because of this reason, Docker came into a picture actually. See, Docker will have, see, Docker will not, okay, please notice this thing. Docker will not have a hardware, okay? Docker will not have a operating system as well. Please notice. So, here is a hardware here, again, coming to a hardware. This is not a hardware of Docker, okay? This is a hardware here. This will be operating system, OS here, and above OS, in case of Docker, there will be a Docker engine. Can say this is another terminology for this is a Docker daemon. There is another terminology of this thing is a Docker daemon. So there will be a Docker engine here. I am representing, see, I am drawing here each and everything because I could have, I have images here, I could have shown you in the images, because here it's very easy to understand, so it will stay longer time in your head. So that is my main thing. So Docker engine, if I talk about Docker engine now, see, above Docker engine there will be a container of application container, there will be a container. Now I want you people to stress, there will be a application container inside, there will be a app. If I'm talking about app means what will be inside? Source code, library file, configuration file, and dependencies all together will make one application. So application will run inside. Okay, so this is the thing here actually in case of Docker. Okay, and this will be in the form of image. This application containers, before it will be in the form of image. This, okay, this much is enough for this. Another demonstration I need to give you. See, so another thing I forgot to mention this thing. See, we was wasting our hardware resources, and you might ask, you people might ask, you people should ask actually, why you people, I don't know, maybe you people are not understanding that. See, hardware, see, we was wasting hardware in case of physical server. So here what Docker is doing, if Docker is creating application here, Docker is means container. See, now again I am coming here, let me demonstrate more deeply actually. So there will be a container here, okay, means Docker will be running inside, like container of application will be running inside. What this container will do, container will take hardware resources of the host and operating system of the host as well. Notice this thing. So if I am creating one container, he'll take hardware resources of the host plus operating system of the host. So we no need to put a licensing for operating system, and we no need to put money for hardware as well. We need to we no need to put a hardware. Here see, basically we are not wasting our hardware resources. This is the thing here in case of Docker. This is the one advantage to have a Docker. Actually, you people need to know the difference between this and that. So this is important here. So another thing, another use of another advantage of using hardware resources. Why we are, you know, so another advantage of why we came into a Docker. Actually, I want you to understand. I'm spending some time here. I'm going little slow here. So because I want you to know what is the each and see. As I said, any application. If I'm talking about application here, please back of the head it should struck. But it will have a source code. Application will have a source code. Okay. See another thing. One developer is working. Okay. One developer is working. What is doing actually? He is writing only source code. He is not writing and source code according to you. People need to think like this now. As a DevOps engineer, I want you to think like this. Okay. The a developer is creating application. This is for 10th student. Okay. This type kind of understanding is only for 10th or 12th student. I want you people to think broader way. We will have a source code library file. Welcome to India. People are making noise here all the time. Dependencies. I am Indian. Actually, I am not from Pakistan. But this is a bad way actually. Library dependencies and config file. The application here and all are educated actually. That is a major problem. People are thinking build education. This is going nowhere. So see, application here. Application will include source code, library file dependencies, configuration. See, please, I want you people to focus here. This application code, the source code will be as per the library file dependencies file and configuration file. Okay. What? Because should be compatible according to, see, if I want to add a dependency, now I'm giving example, another example. See, if I am downloading this application, I'm talking about just take example of SQL database. I'm taking example of SQL database here, SQL. So if I run this SQL application on my operating system, that is OS, can you name some of the operating system here? Mac OS or Linux here. If I talk about Linux here, and another example is Windows. Okay. See, I'm talking about application here. See, if I want to download this SQL application on my Mac OS, the library dependencies and configuration file will be different. Means I have to download different version of my application. That will be separate. If I'm downloading on Linux, same case will be here. Dependencies, configuration and library file means application will be different for Linux. Installation, configuration, each and everything will be different for in case of the Windows as well. But what about in case of Docker here? In case of Docker, as I said, Docker, whatever the can say application will be in the form of image. Means whatever the source code, whatever the library file, whatever the dependencies I have, that will be stored in the form of image. Okay, I'm talking about Docker here. And if I run, anybody, if you people have doubt, okay, you people can unmute yourself and you people can ask me if you want to have some kind, if you have some kind of doubt, if you want to ask something. This will be in the form of image of source code, library file, dependency file and configuration file. If I do a Docker run, there is a separate system here, Docker run. If I do a Docker run, there is a command here. If I do a Docker run, whatever my image name, whatever my application name, that will run inside as a container. Now I'm running an application container now, application container of SQL database, SQL database, and that will run inside my separate environment. This is the advantage. And what is the another advantage of this? See, if I am installing this, okay, I'm talking about SQL. I'm talking about image of SQL here. Yes, please. Sorry, your voice is actually echo is coming from. Yeah, yes, Santosh, please. Yeah, yeah. Actually, your voice is somehow I cannot listen you properly. Actually, I understood you said Docker is a lightweight weight container. Okay, okay, it will contain each and everything. See. Lightweight container. See, lightweight container of what? If I'm talking about lightweight container, right? I'm talking about lightweight container, right? Inside container there will be application running, right? If I talk illogically means, yeah, yeah. We can run the application on top of that or inside that. I'm just saying it. Okay. Yeah, yeah, yeah. Okay, okay. I got you. I got you. Everyone, can you have you heard? Okay. This is the thing here. See, container will be okay. See, container of actually see if I'm using application, there is some specific. See, I want you to understand. I want to make you know. I want you to reach there till you people are not here actually. Okay, you people will understand. See, I'm coming here. Why? Okay, the time I'll teach you people what is the thing inside, you people will understand. Okay, this is very easy to understand, but until now, till now, it's difficult for you to understand what we are doing here. Actually, I'm just trying to demonstrate you people what we are doing here. See, images of SQL. See, I'm talking this in case of images, I'm not talking in this case of content. See, this is a separate entity. Okay, image is a different, container is a different. Notice this, whatever the application, okay, whatever the application we have, this application will be in the form of image. And what any, see, notice this, what any application will have source code, library, dependencies, and each and everything that will be stored in the form of image. Templates of that will be stored in the form of template. Okay, and if I do a docker run command, if I do a docker run command, then our container of that particular application will run. So I no need to go back again where it will run. It will run on a host, because I said, right, Docker container will use the host hardware plus host operating system OS as well. It will be taken from a respective host. Okay, this is the thing here, container of this. Now another thing I was coming here. If I want to install this on my different operating system, if I want to install that on, if I want to configure that, if I want that into a different OS like Mac OS, Linux, or Windows, so we can just pull the image from here. We can pull the image from here. So we no need to have a different library, different dependencies, and different configuration for each OS. We can download same, we can pull, actually there is specific term for this. We can pull the same image for different operating system actually. You people need to understand one hierarchy here. I want you people to understand the hierarchy here. See, and actually it's like this. We have a Docker engine here. Inside Docker engine, we will have a Docker container here. And container can say, okay, I'm just giving you inside actually. Okay. So this is a application here. Hierarchy is like this. Okay. I need to draw an image here. See, hierarchy will be like this. See this one. Okay, I have a Docker host here, can say Docker host or Docker engine here. I'm taking now engine, I'm going more deeper actually. I want you people to understand the hierarchy. There will be a container here. What container will, container is just providing environment actually. Okay, so application, I'm talking about a SQL here, we are talking about SQL here. This will be hierarchy, will be something like this. Okay, in case of a Docker, in case of Kubernetes, it will be different. So we are running container of application here. If I'm talking about application here, now you people need to understand now. See, okay, this is the thing. Now I'm going in practical actually. The people who is having Windows, the people who have Windows, they can do one thing. So just go now. I'm going to installation. So Docker install for Windows. This is the easiest way to practice actually. Another way what you can do is you can practice by creating virtual machine, and you can install a Docker there, or otherwise you can do from um, I think if someone can do from this Amazon, that is from AWS, you people can create the instance there, and you people can practice there, and that can be little slower as well, because this container need if you want to check the configuration here, you people can check the configuration here what we people need. Okay, that much knowledge you people have, I think. So 64-bit processor, 4 GB of RAM, BIOS level virtualization support must be enabled, please. This is very very important. Okay, whenever you are installing this whenever you are installing Docker on your Docker desktop, you need to enable your virtualization support, that is BIOS, and that will be different for in case of HP, Dell, depends upon in some cases, in my case this is F10. With F10 we can go to BIOS, and from BIOS we need to change this virtualization. We need to enable the virtualization support for our Docker container, because Docker is basically also a virtualization, right? Yeah, another thing, we are talking about virtualization here, right? So what Docker is doing? Docker is doing OS level plus hardware level virtualization. It is virtualizing the environment. Docker plus it is virtualizing for both OS plus hardware. It is virtualizing. So now to installation, coming to installation part, you people just need to click here. Okay, just click here and it will download here. Just you people no need to, actually I will cancel this because I already have. So after just you this is a normal installation, not so complicated, so you people will be able to download. So if you people face difficulty, feel free to ask me. Another thing, you people will reach here, this icon will be generated. Before this, I want to show you, I downloaded some of the application, some of the see. Now I'll go more technical. You understood the overview, right? I gave you just a trailer. I see something like if you people wish to go to Hong Kong, so I take you till China. Now I'll take you to Hong Kong directly. Okay, see now, infrastructure. Above infrastructure there will be operating system. This is not a Docker, actually this is a Docker engine. Docker engine will be here. Above Docker engine we will have an application. This is the infrastructure, containerized application. Okay, this will be the environment actually. Okay, all together will be a Docker. So this is the thing here. Now see, coming to a, now I am going to into a practice now. So what you people need to do, if you are downloading this on a window to practice this, just create one folder, normal folder like this. Like I'm creating another one, let me create another one. You people don't need to think like see, you people can do a Docker. This is the simplest way of working. Other way you can work as on a PowerShell as well. So okay, I have another folder here, Docker. You can name whatever you want. You are the boss here. You can name whatever you want. That is not mandatory if you are using Docker here. So CMD. Why CMD on this here? Because I want you to, because you people need to notice this file location. We people are inside Docker now. First command is Docker version. I'll give PPT of commands, whatever the command I'm using. Docker, that is hyphen hyphen version. If I'll select, if I'll do this, I'm able to see the version, what version of Docker I'm using. And if I'll erase those two hyphen hyphen, then I will be able to see this one. See, but I'm getting one error here. This is intentional one. Okay, this is not something, this is just to demonstrate you people. You people will face this one. See, error during connect. This may indicate that Docker daemon is not running. Anyone, any idea what is the problem here? If I check a PS Docker process state, means I'll get the same error. If I do a Docker images, means I'll do the same, I'll get the same error. What is the problem here? See, I'm talking about Docker engine all the time, right? So see what I need to do before going into my command prompt. I need to start my Docker desktop. Okay, Docker daemon. This is Docker daemon, or can say Docker engine. Who is doing the virtualization? Who is doing the thing? Docker engine is doing, right? Docker engine will execute the task, right? So if my Docker engine is not running, then how it will process this? This is the case here. It will be like this. say it will be like this. Actually it will take some time, depend upon your system actually configuration. If your system is good, it will immediately start. So system will play a part. If somebody's configuration is not that good, I recommend them to create the AWS account actually. So you people might ask, okay, you people, we are discussing here as DevOps and you are talking about AWS here. Why? Because we need because this AWS is for what is doing outside. See, um, so AWS access is only is for 1 year actually. See, whatever the container we are going to run here, we can see here. Whatever the images we are going to run here, we are going to see the images here. See, before this I forgot to mention one thing actually. There is a two term here. Two term is coming. One is a image and another one is a container here. See, image. What image is? What image is? Image will contain source code, library file, dependencies and configuration, and that will be in the form of template, means in the form of layer, usually 9 to 11 layers. And base will be a lightweight OS operating system that is of 5% actually. See, I am going to show you interaction, how it's interacting with the host now. See, we will have a guest OS here, right? This is a functioning, actually internal functioning of operating system. See how OS is interacting with the container actually, how it's doing, how he is doing virtualization here. See, we will have a 5% of guest OS that can be of Alpine Ubuntu's lightweight container actually. Very small. I think Alpine image will be around 5 to 7 MB. Ubuntu will be little bigger. So what it will do actually, this is the image here. Image will be in the form of layer. Our image will be in the form of layer. Now you can understand layer means we will have a layer of dependencies, configuration file, library file. Now I'm coming here. See, top of the layer, we will have an application. What application? We will have application source code. Please notice this, we will have application source code. We will not have application actually. What people are saying here is we will have application here. Directly you people need to think like we will not have full-fledged application here, means we will have a dependencies here. The time I'll actually see, the time to create the Docker image, I have to write the Docker file. Okay, there is a system here. Okay, there is a system here. I have to write a Docker file here. The time I'll write the Docker file, you people will understand the layered system of image here. You people will understand the layered system of image here. Why? Let me write proper one. So layered system you will understand. So because as per image we have to configure, we have to create the layer, that is Docker file. Okay, that is not for now, that will I'll reach here after 5 or 7 lecture. So see, base will be Alpine, and after there will be, you no need to go very deeper. This much of information is enough for you, whether you are a senior DevOps engineer, whether you are a beginner, or yeah, anything. So this much information is enough. So how it's going to interact? See, this host OS is going to interact with the containers, whatever the 5% of container, whatever the 5% of this, whatever the 5% of container we have in the image, this is going to interact with. This is the logical, this is the technicality behind virtualization here. But in interviews, whenever you are appearing for interviews, because don't, please don't say this, because not many people have the understanding of this much. So that guy might argue, because if somebody is taking, see, first technical round, who is taking your technical round? It's a team, it's not a team leader. Sometime, the people who is the person who is working in a team, he will be a normal person or another person. It might be your team leader, he will take your interview. The time he'll take an interview, actually he won't have this level of understanding actually. If you are talking this with a manager or a higher rank person, he will understand the technicality of this. If we'll talk like this, 5% of container we will have, 5% of OS we will have in the image, then he will start arguing with you people. So I don't want you to have, be in there. So see, this is the technicality here. Image will be in the form of template, source code, library, dependencies, and configuration file. Each and everything will be configured inside. And if I do a Docker run, then our application container will run. Okay. To justify this, I'm coming here again. See, my Docker daemon is running. It must be running like this. And after running, see, if I write a command like this. If I do a command like this, and the second thing, I want you people to browse here. Please spend some time here. This is a cloud integration. V1 0.331 version is this one, API version is this one, Go version is this one, Docker engine version is this one, 23.0.5. Before I was talking about Docker, now I'm talking about container, now I'm talking about images. Before, after images, I'm talking about the container application, containerized application. Now I'm talking about Docker engine here. See, I'm going more deeper now. Okay, I'm sending you people to Hong Kong now. Okay, so this is the thing here. Final target. Hong Kong means final target. Okay, don't plan tomorrow. If you're planning tomorrow, you can invite me too. So see, version is 1.1.5. I want you people to go here. As we move ahead, as we proceed with the class, as we move with the class, you people will understand the technicality behind this. So another thing is, so I'm talking about images all the time, right? I am making you people irritated. What is the images? See, so where it will be stored? It will be stored in a registry. Can say there is a separate term. I want you to notice this: registry or Docker Hub. Storage means basically we will have a images here. We can. This is a pre-built image. Okay. And another thing, we can build our image by own. We can build by image by our own, or we can pull the image from here. See, I'm talking about Alpine. Alpine is operating system to one of the kernel, can say lightweight container. So see Python. Okay, Python here, one to here. You people can, and another thing, please browse here too. So I want you people to browse here too. So let me check here. See what we have, 1 billion plus downloads, and I was talking about size, right? Only 5 MB of size. And another thing, what do you mean by tag? If you are talking, tag means you are naming something, right? So tag means version, different version of Alpine. This is the different version of Alpine. So see, I was talking about Docker image, right? This is a Docker image. I want you people to browse a little bit so you people can understand some, some basic understanding you people will have. So see, Docker pull Alpine. So what I'll do actually, I'll do a simple Docker pull Alpine, and if I'll do a Docker pull Alpine, see, it will pull the image from Docker Hub to locally first. Okay. Now see, pulling the local. See, this is available locally actually. See, already exists. Okay, this image is already locally. So how I can see Docker image? If this image are not locally available, then it will download from the Docker Hub. Okay, so what Docker pull will do, Docker pull will download the image first locally. Please notice this: first it will download the locally. Now this is available locally. Now please notice here, repository is Alpine, tag is latest here, image ID is this one, created before 9 days ago, size is 7.33 MB. Created doesn't mean it is created before 9 days ago. I said, what do you mean by version is? Version is slight modification of previous build. Actually, this was created before, but there is a slight modification in this. So whatever the modification we did, that happened last time, happened before how many days back? 9 days back. So now if I want to see Docker images, to see the Docker images, I can see the here, Docker images. I have only one image. Now see, if I want to pull the Python image, okay, I let me pull the Python here. You people can search from here, or either you people can explore here. Just need to go here, just write it down, Docker Python, Docker pull Python. Now see, I want to give you people difference here. See, I did Docker pull Alpine, tag is latest, means it automatically, it will, if I'm not giving tag here, automatically it will download latest version of my image. And if I'm giving a tag, how I can give a tag? You people can see the notice, you people can see the different version here, Alpine. I am typing Alpine here. This is a version, different version of Python. So I am separating this by colon. I don't want you people to remember the command. I want you people to understand how to make the command. Okay, colon alpine. If I do a colon alpine means I will be able to download the Python alpine version. Okay, what happened here? See, can you see what is the Docker version? Yeah, see here. See, and another thing you people can see here, right? It's downloading in the form of layer 1, 2, 3, 4, 5, and whatever the layer already exists. Whatever the layer already exists means, see, I did pull Docker pull Python Alpine image before. Some of the layer remained actually. If I, if I remove the image as well, some of the layer remain sometime. See, some of the layer remain sometime. So whatever the layer I don't have, it downloaded those. Okay, to see again Docker ps, again Docker images now. See, I can see the Docker images. Now let me run the container out of this. Docker run. What I need to do, Python, and what was my version? Separated by a colon. The version is Alpine. So if I do a Docker run means it will run as a container. See, there is nothing here means how I can check here? Docker ps hyphen a. You can see here, this is a container here, container id. This is the image here. This is a command created 9 seconds ago, exited 8 seconds ago, and this is the name given actually. Okay, this much of information is enough for today. Tomorrow I'll come with more command lines actually. So any doubt here? If you people have any kind of doubt, as we move within the class, you people will understand. But still, if you people have doubt, you people can ask me. So okay, so I'm closing here now. So see you guys tomorrow, same time. Not tomorrow actually. Tomorrow is Saturday. Tomorrow is Saturday, right? So we'll connect on Monday actually. Sorry.